Okay, well, our general solution is the general linear combination, the general vector within this space of functions, which are vectors. General solution is this. So y of 0 equals c1 e to the 0 plus c2 e to the 0. And that's obvious that you're going to get e to the 0 here since t is going to be 0. And that equals then c1 plus c2, which is 0. And then y prime of 0 equals negative 2c1, because when you take this derivative, you get negative 2c1 e to the negative 2t. And e to the negative 2t is still 0, so you're going to get negative 2c1. And similarly over here, you're going to get minus 3c2. And that has to equal 1, giving you two simultaneous equations to solve for c1 and c2. And I'm not going to go through the formal way of doing that. You can set up a matrix, do an inverse matrix, you can do all kinds of things, reduce the matrix. But the straightforward thing is, for the first equation, we get c1 equals negative c2, so that negative 2 times negative c2 minus 3c2 equals 1. And from this, we very quickly get c2 equals what? Well, that's 2c2 minus 3c2, so c2 better be negative 1.
Right.
Does that agree with what you got? So we're justified in doing this quickly. Okay?
Right.
And then c1 is negative c2, c1 equals 1. So our particular solution, because we've used the word before, particular solution means the specific solution with the constants evaluated. The particular member of this subspace that satisfies these conditions is y of t equals, left myself enough room, let me write small and make sure. C1 is 1, so we get e to the negative 2t, and C2 is 2, negative 1, so that's then going to be minus e to the negative 3t. Now to check, we would substitute this back into the equation. If we've done our work correctly, it's going to work, it's going to fit. And if you've made a mistake, it'll show up right away. Okay? And then we check and make sure that if t equals 0, this is 0. Well, that's very clear. You have 1 minus 1, right? And that C2 prime is equal to 1. Okay? So Y2, that Y prime is equal to 1. Y prime of 0 is equal to 1. Okay? So we can check this solution against our equation and against our initial conditions, and we'll find out that we're in good shape.